question 9 is typically the hardest question on the paper. And so question 7 is getting hard. This is a sum and product of roots question, quite a small topic. And so you've got to, first of all, you've got to spot it and you've got to know what to do. There is stuff on the formula book, but it's kind of nicer if you actually understand it. And what it is saying is we have a polynomial that has these roots, and it is a tradition to use these Greek letters here, and one of the sort of indicators of the topic you're in. And then we're going to extract a bit of information from that, and then almost certainly simultaneous equations. That's where this question is going. Let's just understand it first. If we have a cubic or any polynomial, here's a quartic. If we can factorize it, it will look like this. Notice it has a 1x to the power 4 or 1x cubed. If any other number is there, just divide through by it. We must have a 1. Okay, so the question is, what is the constant here? If I multiply this whole thing out, what constant will I get? There's only one way of getting a constant, which is alpha times beta times gamma times delta, but notice they're all negative by the nature of factors. So here, the constant will be this. Notice because there's an even number of them, it's positive, but there's an odd number here, so it'll be negative. So we can write this down. The product of the three roots is equal to the constant, and you put a negative sign in there if you're looking at an odd ordered function. So let's have a look now at the second term along, not that one. It's obvious where that one came from. X times X times X times X. What about the one next to it? X cubed. That means I have to hit all of these brackets apart from one. So X times X times X times delta. Or I could have X times gamma times X. Or the other two. So I'm going to pick out each of these and add it up. And it will look like this. In every single polynomial, it will look like this. Notice this minus sign here because they are all negative. And so this is the sum of the roots. The sum of the roots is equal to the negative of whatever the coefficient of the next term along. Be super careful that it is, if it's a cubic, it's the squared term. If this had read x cubed minus kx plus 3k, then the coefficient of x squared would have been 0. However, this one is straightforward. So the sum of the roots here is alpha plus beta is equal to the negative of negative k. And I've also written the third one that was just given in the question because this is simultaneous equations. I'm trying to get organized. The first thing I would do is, can I say to myself, can I tidy things up? Do I want to multiply that out? No, that feels like it'll be harder. I can certainly tidy this up. Alpha plus beta is 2 of those. And basically, difficult simultaneous equations, you're looking to substitute one into the other. And this one's really nice. If you look at it, can you see any substitutions that can be made? Well, we can substitute both the middle and the bottom directly into the top. And so we're always trying to get an equation that has one unknown in it. So I took the alpha beta, put it into here. I took the alpha plus beta, k over 2, and put it into there. And I've ended up with this equation that I'll leave you to solve to find k.